Hello everyone, today we are going to start with simultaneous equations. One important thing to mention is that simultaneous equations are one of the most fundamental things that you need to know before starting out with your O-level Maths or Maths Day syllabus. Before diving into simultaneous equations, I want to first look at our normal equations. Let's say we have an equation of 2x plus 2 is equals to 4. Now what do we do in here? What we try to do is that we try to solve or try to find the value of our variable x. So in this case, what we can do is that subtract 2 from both sides of the equation, which leaves us with 2x is equals to 2. And then we can divide both sides of the equation with 2. That leaves us with x is equals to 1. Now this was a very simple equation to solve. But simultaneous equations are a little different in this case. The first difference being that simultaneous equation contains 2 or more variables. Okay. So just like I said right now, in simultaneous equations, we not only solve for x, but we also have to solve for another variable such as y. Another important thing to see in simultaneous equation, that is the number of variables has to be equal to the number of equations. So in this example, let's see an example first of all. Let us first see the example of our normal equation. That was 2x plus 2 is equals to 4. Now in this case, how many variables did we have? We had only one variable. And how many equations did we have? We only had one equation. So in this case, we were able to solve for the value of x because the number of variable and the number of equation was equal. But let's say we have a set of equation 5x plus 2y is equals to 25. Now in this case, and this is a simultaneous equation, we have two variables here, but our number of equation is only one. So this is practically not solvable as the number of variable is more than the number of equations. Now in this case, what simultaneous equations does is that we do not have a single equation. We have a set of two equations. Let's say our second equation is 2x plus, let's say minus y is equals to 1. Now this is our second equation. Now we can solve for our variables x and y because the number of variable and the number of equation is the same. So this is what basically simultaneous equation is. We try to solve two equations simultaneously to find out the value of the variables. Now we are going to explore the methods in which you can solve simultaneous equations. The first and the most easiest method being elimination. Now what we try to do in elimination is that we try to subtract or add our equations so that we can eliminate a variable from our equation. Let's say in this case, I want to add equation 1 to our equation 2. Now if we try to do that, and right now what I'm planning to do is that I'm planning to eliminate y from a set of equations. So if I try to do that, for y it will be 2y minus y, which leaves us with y. Now right now we are not able to eliminate y. To tackle these kind of cases, what we do in simultaneous equation is that we can only multiply and try to find the LCM of our coefficients so that they end up with a 0, which means elimination. So right now the coefficient of y is 1 and the coefficient of y in our first equation is 2. So if I multiply our equation 2 with 2, we can change the coefficient of y to 2. Now in this case, that is 2y minus 2y, that leaves us with 0. That means y can get eliminated. So in this case, what we are doing is that we are multiplying equation 2 with 2. So initially our equation 2 was 2x minus y is equals to 1. And now if I multiply our equation 2 with 2, we get, I want to multiply it with 2. So 2 times 2x is equals to 4x, 2 times minus y is minus 2y, and 2 times 1 is 2. So this is our equation when we multiply it with 2. The format for elimination is very simple. First of all, you will write the first equation, 5x plus 2y is equals to 25, and then you will write the second equation, multiplied by 2 in this case. Since we are trying to LCM the coefficient of the eliminating variable so that they eventually eliminate. So this will be 4x minus 2y plus 2. That is 4x minus 2y is equals to 2. And right now we are trying to add the equations, so here will be plus sign. So we are now just going to vertically add the terms with each other. So if I try to vertically add 5x with 4x, that will be 9x. And if I try to add these two, they cancel each other out. So if they cancel each other out, this gives us a 0, and then 25 plus 2 is 27. Now this was the point of elimination. We have successfully eliminated our variable y from our equation. Now this becomes a very simple one variable equation to solve. So this is what we try to do in elimination. We try to LCM the coefficient of the variables that we try to eliminate. So if we try to solve this equation, that is 9x is equals to 27. And now if I divide both sides with 9, we get x is equals to 3. As you guys can see, we have already found the value of one of our variables. So x is going to be equals to 3. Now what we have to do is that we have to find the value of our second variable, that is y. To do that, what we do in simultaneous equations is we substitute the value of x into any of the equations. Now in this case, any of the equations can work. You can substitute the value of x is equals to 3 in our equation 1, and also substitute the value of x is equals to 3 in our equation 2. And I prefer equation 2 because it is a much simpler calculation. So our initial equation was 2y is equals to 1. And now if I substitute the value of x is equals to 3, that becomes 2 times 3 minus y is equals to 1. So it is going to be 6 minus y is equals to 1. And now if I subtract 6 in both sides, that is minus y is equals to minus 5. And then if I multiply both sides with minus 1, minus minus cancels out, so we get y is equals to 5. So we have successfully found out the value of our two variables. Now just like I mentioned earlier, you could have also put the variable of x in equation 1. It will still give the same value. Let me show you guys the practical. So our value for x was, for x is equals to 3, we got 5x plus 2y is equals to 25. Now just substitute the value of x, that is 5 times 3 plus 2y is equals to 25. So that leaves us with 15 plus 2y is equals to 25. And if I subtract 15 from both sides, that leaves us with 2y is equals to 10. And if we divide both sides by 2, we get y is equals to 5. So as you guys can see, the value of y is still the same. So this proves that it doesn't really matter in which equation you put the value of our variable x. It will still give the same result. Now we will be seeing the second method to solve simultaneous equations. So the name of the second method is substitution. Now there is an advantage of substitution over elimination. To understand that, you will have to first understand the two types of simultaneous equations. The first one being linear and the second type being nonlinear. The key difference between linear and nonlinear equation is that in linear, you have the variables either added or subtracted. Wait, let me write it. Either added or subtracted. Now, as you can see, this is a set of linear equations. You can see that the variables are either added to each other or subtracted from each other. Now, for nonlinear equations, the variables will be multiplied to each other or have a power greater than 1. So in our linear equation, as you guys can see, the power of both of our variables is 1. But in nonlinear equation, the power can be x square or y square or anything. So when you guys see that in a set of simultaneous equation, the power of x and y is more than 1, then you guys will have to identify it as a nonlinear equation. And another thing when an equation is nonlinear is that the variables are multiplied inside the equation. Let's say we have a set of equation that is 2x plus 5xy. It gives us 8, and then let's say 3x plus y is equals to 5. Now this is a nonlinear equation. As you can see, even though in the second equation x and y are added with each other, in the first equation there is a term where x and y are multiplied with each other. So this is a nonlinear equation. Now the advantage of substitution over elimination is that you can use substitution for both trying to solve linear and nonlinear equations. But you cannot use elimination to solve nonlinear equations. You can only use elimination to solve linear equations. So this is a very big advantage of substitution over elimination. Not advantage, this is a necessity. You cannot solve nonlinear equations using elimination method. Now you might be asking that then why can't we use substitution for both the cases, like for nonlinear and linear equations? Why there has to be two methods to solve a set of simultaneous equation? Now this is based on simplicity. Like in elimination, it is much simpler, like compared to substitution, to solve linear equations. But as you know that you cannot use elimination to solve nonlinear equations, you must have to use simultaneous equations. But yeah, the benefit is that you can also solve linear equations using using substitution. Now I'm going to solve this same set of simultaneous equations using substitution. So in substitution, what we first do is that we try to subject any of the variables as the subject of the equation. Let's say I'm taking our equation 2. 2x minus y is equals to 1. Now what I will do here for substitution is that first I will subject any of the variables. Let's say I want to subject x, but there will be no problem if you try to subject y as the subject of the equation. So 2x is equals to 1 plus y, and then x is equals to 1 plus y by 2. So I have made x as the subject of the equation. Now this becomes my first equation. Like from this I simplified it to making x the subject of the equation. Now what we do is that we will use this value of x. The value of x right now is 1 plus y by 2 inside our equation 1. So let's say for x is equals to 1 plus y by 2. Now what I'm going to do is that I'm just going to substitute the value of x inside our equation 1. So initially our equation 1 is 5x plus 2y is equals to 25. And now if I substitute the value of x, this becomes 5 times 1 plus y by 2 plus 2y is equals to 25. Now if I multiply this with 5, now we just have to solve for y. And as you can see, we were able to eliminate again one of the variables, that is x. Now we are just trying to solve for y. Simultaneous equations, what we do is that we use the methods to make the set of equations into a single equation, single variable equation, and then solve for that single variable. So if I multiply 5 with this, we get 5 plus 5y by 2 plus 2y is equals to 25. Now if I multiply both sides with 5, that leaves us with 5 plus 5y plus 4y is equals to 50. And then if I simplify this, 5 plus 9y is equals to 50. And then 9y is equals to 50 minus 5. So 9y is equals to 45. And hence if I subtract, if I divide both sides with 9, y is equals to 5. So as you guys can see, the value of y in using substitution and the value of y that I found using elimination are the same. That proves that our answer is correct. And this proves that you can use any of the methods based on your preference to solve a set of linear simultaneous equations. Now what I'm going to do is that, let me erase this first. Yeah. So finally I got the value of y is equals to 5. Now this is the same as elimination. I will substitute this value of y into any of the equation, and just like elimination, both of the equations work. I can substitute the value of y in both of the equations. So for simplicity, I'm going to go with equation 2 for simpler calculations. That is 2x minus y is equals to 1. So if I just substitute the value of y is equals to 5 for y is equals to 5, 2x minus 5 is equals to 1, 2x is equals to 6. Okay, let me do it in a detailed way so that it's easier for you guys to understand. So 2x is equals to 6, and therefore if I divide both sides with 2, we get x is equals to 3. So as you guys can see, the value of our x is still equal to the value of the x that we found using elimination. Now this is all you need to solve linear equations. Linear equations are much simpler. Now I'm going to show you guys how to solve nonlinear equations. And as I have told you guys earlier, that we can solve nonlinear equations only by using substitution method. As you guys can see, we have a set of nonlinear equations. As I have mentioned earlier, to identify if an equation is nonlinear, you have to look for either the power of any of the variable is greater than 1, or that any of the variables are multiplied with each other. And you guys have also noticed that the first equation in our set is a linear equation. Now this has no effect. You still have to use substitution to solve nonlinear equation, as you will need both of the equations to solve for our x and y. Now to do this, what we do in substitution, first of all, we will have to subject any of the variables as the subject of the equation. Now I will highly recommend you guys to go with the linear equation, as it is very hard to subject nonlinear equations. So we are going to do the linear equation first. So initially our linear equation was this, and right now I want to subject, let's say, x. So 2x is equals to 7 minus 2y, and if I divide both sides with 2, that is x is equals to 7 minus 2y by 2. Let me fix my handwriting so it's easier for you guys to understand. Now this is a newer version of our equation 1, and this one is the one what we will be using from now on. So in substitution, what we will do is that we will replace the variable x in our nonlinear equation with the subjected equation that we found right now. And basically this is right now the value of x. So for this, in substitution, what we write is that equation 1 in equation 2. I'm trying to say that we are putting equation 1, which is the value of x, inside equation 2. So in that case, our second equation is x square minus 4y square is equals to 8. So if I substitute x here, that becomes 7 minus 2y by 2 whole square minus 4y square is equals to 8. Now we just have to simplify this, and you guys have also noticed that we were able to eliminate x. That is the point of simultaneous equations. We just try to eliminate any of the variables, so that it becomes a single variable equation which we can easily solve. Now this is a simplified version. And another important thing I want to mention, that is there is an identity a plus b whole square, which is a square plus 2ab plus b square. Now in this case we have 7 minus 2y whole square. Wait, let me fix my handwriting again. Okay, so right now 7 is acting as the a and minus 2y is acting as the b. So first of all, we will have a square, that is 7 square is 49, plus 2 times a, that is 7, and then times b. And don't take b as only 2y, you have to take b as minus 2y, plus minus 2y whole square. Now we just have to simplify it. So 49 stays as it is, and then 2 times 7 is 14, and 14 times minus 2 is minus 28. And as you guys can see, we have a minus sign here, so it will multiply with all the positive signs and make it a negative sign. So it will be 49 minus 28y plus 4 square. Now we'll just have to put this inside our equation. So here we have 49 minus 28y plus 4y square divided by 4 minus 4y square is equals to 8. 49 minus 28y plus 4y square. Okay, wait, I have to go down. Minus 6. Oh, by the way, this is part of the equation. I just didn't have enough space. Minus 16y square is equals to 4 times 8 is 32. And by the way, guys, do not forget to also multiply. Like I said, both sides of the equation. Like some people make mistakes where they only multiply one side but forget to multiply the other side. So now we just have to simplify this. So that leaves us with 49 minus 28y minus 12y square is equals to 32. So when now if I simplify it more, that is 12y square minus 28y, and then 32 minus 32 minus 49, that will be plus 17 is equal to 0. Now for simplicity, I want to multiply the entire equation with minus 1. That will leave us with y square plus 28y plus 17. Now why I did that? It is just for simplicity. It's easier to solve quadratic equations with like when the coefficient of my y square or the y square is either positive. Let me erase this to get some space. Okay, now I was solving the equation here. That will give us, okay, so what is 12 times 17? 12 times 17 is 204. That is 12y squared plus 28y plus 204 is equals to 0. So now let us list like, oh, sorry, what am I doing, man? So this was 17 and this was 0. Now I will just have to see which, like by adding or subtracting, we get 22. Oh, sorry, 28. So 204 can be 1 into 204 can be 2 times 102. Is it divisible by 4? It is 4 times 51. No, I don't think it's divisible by 5. I think it's divisible by 6. 6 times 34. And oh wait, I think we got it. So if you like 34 minus 6 gives us 28, right? So this will be 12y square plus 34 y minus 6y plus 17 is equals to 0. So if I take y first, y 12 plus 34. Oh wait, oops, I made a mistake here again. This will be minus. I multiplied the entire equation with minus, right? So okay, this one will be plus. All these ones will be minus. Okay, so if I take y, that will be, okay, wait. We take y, that is 12y plus 34 minus, if I just take minus 1, that will be sorry. Oh wait, I can take 2y from here. I can agree that this is a little hard equation for a first example, but yeah, we can adjust. So that will be 6y plus 17 if I just take minus 1 here, that gives us 6y plus 17 is equals to 0. Now this leaves us with 6y plus 17, 2y minus 1 is equals to 0. So first of all, wait, let me erase more. This part, I have to erase this part. Okay. So yeah, we have a lot of space right now. So first of all, we had 6y plus 17 is equals to 0. So 6y is equals to minus 17. And then y is equals to minus 17 by 6. And then another one we had, that is 2y minus 1 is equals to 0. So 2y is equals to 1. And therefore y is equals to 1 by 2. So we got two values of y here. Now I just have to find the corresponding value of x for this. Let me clear the screen more. I can clear this first. Okay, all right. So we got the values of y as y is equals to minus 17 by 6 and y is equals to half. So now we just have to find the corresponding values of x. So first of all, for y is equals to minus 17 by 6, we have x is equals to 7 minus 2 times minus 17 by 6 by 2. So if I just have to simplify this, so 2 cancels out 6, so it's 3, and therefore 7 minus 17 by 2. Oops, what am I writing, man? 7, okay, plus minus multiplies to plus, then 17 by 3 by 2. Okay, so I will keep on simplifying. That is going to be 21 plus 17 by 3 by 2. So if I move here, it's going to be 38 by 3 by 2, which is going to give us, I think, this is going to be yeah, I'm bad at maths. Okay, so that is going to give us 19 by 3, which turns out to be 6 whole 1 by 3. All right, so as you can see, we have found the corresponding value of x for the corresponding value of y. So in our answers, the first set of x and y, the values of the variable is 6 whole 1 by 2, and for y it will be minus 17 by 6. And now the same set of values which we are going to find right now, x is equals to 7. Oops, wait, first of all I will have to write 4. Oh wait, for the same set of values x and y, for x is equals, sorry, for y is equals to half, my bad, is equals to half, we got x is equals to 7 minus 2 times half by 2, so 1 cancels out, so 6 by 2, which is x is equals to 3. So the second set of values is 3, and then y is equals to 1 by 2. So this is our set of answers, and that's all. I think that's all for simultaneous equations. In this video we have learned the two methods to solve simultaneous equation, and also how to solve linear and nonlinear equations. So basically this is the basic theory of simultaneous equations, and now all you have to do to get better in this topic is to keep on practicing hundreds of problems. Now I will be giving you guys a video where I'll be practicing with you guys a total of 20 problems of simultaneous equations. So if you want to practice right now, you guys can check that video out. And thanks for watching this video, and please also consider liking and subscribing, since I'm a very small YouTuber, and yeah, it helps me a lot if you guys keep on supporting me like that. So thanks for watching. I hope this was helpful and helped you learn simultaneous equations in a much better way. So that's it for today.